There was some audio problem, it seems. Now it is rectified. Is it okay now? Right. Now let me go through the first set of alkane, alkene, alkyne. Likewise, we have got nearly about 11 types of groups. We will discuss one by one. Alkane, it has CnH2n plus 2 formula, whereas alkene CnH2n, alkyne CnH2n minus 2. So let us work out one by one. Alkanes CnH2n plus 2. You too can draw a table like this so that you can develop a the cheat sheet that is all in a single page, so that it should be very useful for your memories. Now CH4 methane, that is you can apply CnH2n plus 2 formula. So C1 2 into 1 2 plus 2 4. So CH4 methane. Similarly, we have ethane, which is nothing but C2H6. So CH3 CH3, you can apply the same formula. So this is CH3 CH3. Similarly, CH3 CH2 CH3. So you can add these carbon atoms. So C3 and add these hydrogen atoms. Number of hydrogen atoms 3 plus 2 5 plus 3 8. So it means C3H8. You can write C3H8, and this is the formula, that is a propane. Then similarly, prop means a 3 carbon atom, and you can apply similarly butane for 4 carbon atoms, CH3 CH2 CH2 CH3. So this is butane. And for pentane, C5. So C5, what could be the molecular formula for pentane? Let me write. If you are given a formula like this, I mean nomenclature like this, you should be able to write down the formula. For example, just look at this pent. Pent means a 5 carbon atom. So straight away you can put 1 2 3 4 5. So this is the way you can develop the molecular formula also from the IUPAC name. And ane means, that is alkane. So it is pretty clear that you have got only alkane. So only CC single bonds. Now we have already drawn 5 carbon atoms in a single chain, and what you have to do is, that is fill up with the hydrogen. Ensure each carbon atom should have 4 valencies. For example 1, and here you can put 3. Is it not? So 3 plus 1 4. Similarly 1 plus 1 2. So you can put 2 hydrogen. 1 plus 1 2. So you can put 2. 1 plus 1 hydrogen. So 2. And here only 1 bond. So you can include CH3. Otherwise you can draw like this also. Okay. Now that is the terminal atom always will have CH3 like this. Is it not? So I written in a simple way. And what about this one in between? HH. So CH2. HH CH2. So to start with, you can have such type of practice, and once you have expertise means, so you can adopt this method. Okay, so put hydrogen, hydrogen, hydrogen. Is it clear? And you can have the simple bond formula like, that is 1 carbon atom, 2 3 4 1 2 3 4 5. So this is also pentane. Okay, so each terminal, the terminal has CH3. In between that you have CH2. Okay, so you can write CH3, CH2. You can write down CH2, CH2, CH3. Or you will follow? Right. So this is pentane. Okay, and similarly you can draw hexane. Hexane means a CH3, CH2, 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 CH2. That is CH2 you can simply put 4 times and put terminally CH3. So you just add CH2 4 times means C4 times C4, and there are 2 carbon atoms. So C6, and you can count the hydrogen also. So 3 plus 3 6, 6 plus and 8 14. Is it not? For instance, hexane. So here 1 2 3 4 5 6. Write down 6 carbon atoms, and you can fill up with hydrogen. So CH3, CH3. Okay, in between that you can put CH2, 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 CH2. Instead of repeating so many CH2s, you can simply put CH2 and 4 times, 1, 2, 3, 4. So 4 times and put CH3. So this is also hexane representation. Is it clear? Otherwise you can do one thing, CH3, CH2, 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 CH2. 1, 2, 3, 4, 5, 6. This is also hexane. Okay. Otherwise you can draw like this, CH3, CH2, 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 CH2. Simultaneously you have to count CH3. So terminally you know these are CH3. Okay. Right. And now let us go ahead with alkenes. Alkenes essentially they have double bond. Okay, so there should be one double bond. And what is the general formula? CnH2n. Okay, so CH2 double bond CH2, which is nothing but ethene. Okay, so C2H4, and we want to develop further. So prop, we know prop means 3, but 4, pent 5, hex 6, hept 7. Likewise you can proceed. So here I written propene. So how you can write propene? C, C, C. Write 3 carbon atoms and then put double bond. Okay, then fill up with hydrogen. I already insisted that you should have 4 valency at each carbon atom. So there are already 2 bonds. So how many hydrogen atom can be put here? 2 hydrogen. And what about the terminal one? 3. And in between that 1, 2, 3 bonds are already there. So you had to put only CH. Okay. So how can you write this? CH3, CH, double bond CH2. Okay. And you can also write like this, CH3, CH2. So this also represents propene. Are you able to follow? So try to write with different types of representations of structural formula. And this is called 1-propene. Of course, 1-propene means it indicates the position of the double bond. Okay. So here, whether it comes at the right or left, okay, it is always 1-propene, irrespective of the position. Here, similarly, 1-butene. Okay, buta means what? But means 4. So butene, 1-butene means double bond is present at the which position? First position. So C, 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 C. So 4 carbon atoms are put because buta means 4. Ene means double bond. Where is it present? It is indicated by the number. So you can put simply double bond here. Right? Now fill up with the hydrogen. So terminal CH3, in between CH2, and in this position CH2 because you have got already double bond. So here 2 plus 1, 3. So you can insert only one hydrogen. Okay. So if you want to write like this, you can write, nothing wrong. You can put CH2 like this. Okay. So the bond line formula can be 1, 2, methane, ethene, propene, butene. That's all. So 1, 2, 3, 4. So CH3, CH2, CH, CH2. Got it? So all of them represent butene, 1-butene. Now you can have 2-butene also. How? Just you locate the double bond in the second position. So that is called 2-butene. Let us try 2-butene. Write down. 2-butene means 2-butene. That is buta, 4 carbon atom, and ene double bond is there, and where is the position? Second position. So from here it is second. Now you can write down CH2 CH3 CH CH, got it? And this is CH3. Okay, so ensure the tetravalency of carbon atom. Here 4, here also 4, 4, 4, finished. So how can you represent this? By bond line 1 2 3 1 2 3 4. So second position double bond. So butene. Okay, so this is known as 2-butene. Can you write down 3-butene just by dislocating the double bond to the third position? It is not possible. Why? Because it gives the first position as far as the lowest number rule concerned. You may say, sir, this is first position, this is second position, this is third position, this is fourth position. Okay, so when you mention like this, you cannot claim that this is the second carbon atom. You have to go for the first one only. So according to lowest number rule, you have to say 1-butene. Okay, what about this? So when I bring here, it becomes 2. 1, 2, 3, 4. So it 2-butene. It is 2-butene. And similarly, is it possible to draw in the third position? It cannot be. Why? Because you can write from here and claim that it is 1-butene. Because in Iupok rule, there are two important rules. One is longest chain rule. Iupok, note down. Longest chain. The chain should be longest. Longest chain rule. And the next is lowest number rule. So these two should be very, very important. Lowest number rule. It means it indicates the position of the double bond or triple bond, or also the substituent, the position of the substituent also, and also the functional group. Okay, right. Now let us proceed with butene. We have already done butene, and what about this 1-pentene? So you have to write down 5 carbon atoms and put. So let us try to give the various nomenclatures and various possible structures for pentene. Okay. Pentene. So this pentene can be 1-pentene. Let us start with 1-pentene. So write down 1, 2, 3, 4, 5 and put a double bond on the first position. So this is one chance. What is the next chance? 1, 2, 3, 4, 5. You can put 2-pentene. So that is also possible. And let us check for 3-pentene. 1, 2, 3, 4, 5. If you do like this, from here it becomes 2. So this is ruled out because this is similar to the second one. Okay, and that is why you have to stop with that. So we have now what is that? 1, 2, 3, 4, 5. So this is called 1-pentene. So you can draw by inserting 3 hydrogen here, 2 hydrogen here. Why 2 hydrogen? You should satisfy the tetravalency of carbon atom. Tetra means 4. So CH2, and here CH2, and here CH only. Got it? And similarly, what is this? 1, 2. So 2-pentene. Okay. It can also be called a pent-2-ene. And the third one is, this is ruled out. Okay. And but we can that is branch it and get another alkane. Like, let us branch this. Let me put CH3. So it's a different compound, different isomer. CH. So 1, 2, 3, and then put CH2. So this is possible. So let us remove this and insert this. And how to name this compound, and before that let me complete this. So 2-pentane means CH3, CH3, CH2, and here only H, here only H. Are you able to follow? So every time you have to check whether the carbon is satisfied with the 4 valencies. But when you compare these two, this is branched, okay, and but we have to consider the longest chain. So either you can take like this or like this. So let me take the chain like this. Okay. Now I can count. Where from I have to count? The important one is now there are double bond and there is a substituent here. This is called substituent. When there are substituent and main functional group, you have to give importance to the functional group. So here there is no functional group, of course. Here you have double bond, so you have to give importance to the double bond, and that should give the lowest numbering. So we have to give the lowest numbering for this. So in that case you can start like this: 1, 2, 3, 4. Okay, so it means 1, 2, 3, 4. 4 means what? Butane. So this is 1-butane, where in the third position there is a methyl group attached. So you can call it 3-methyl 1-butane. Are you able to follow? So 3-methyl 1-butane. Okay. Got it? So you should be able to derive the possible isomers from the given nomenclature or compound also. Right. Now let us proceed with the next set, that is CH3. This is one hexane, that is support 6 carbon atom, and at terminal near the terminal carbon atom you can put double bond, so that you are able to get 1 hexane, that is with the 6 carbon atom. An alkene with the 6 carbon atom. An alkene with the 7 carbon atom is called heptane. So you can form a chain. Okay, right. So now let us proceed with the next set of elements, members. Alkyne. What is the general formula? CnH2n minus 2. Okay, it should have triple bond essentially. So C triple bond C. Now we have to fill up with the hydrogen. 3 plus 1, 3 plus 1. That's all. So this is ethine. So the first member is ethine. Second member. So here you can put once again 3 carbon atoms. 1, 2, 3, and draw 3 triple bond, 1 triple bond, and fill up with the hydrogen. CH3 H. You cannot introduce any hydrogen here because it is already satisfied with 4 valency. Okay. So what do you call it? Propyne. Take down propyne. So this is the way you have to write. And third one, 1, 2, 3, 4. So put triple bond. Now fill up with the hydrogen. Very simple. CH3, CH2, C triple bond, CH. That's all. So what do you call it? 1-butane. can you write 2-butane? Let us try. 2-butane. Let us try both. We are already given butane. So 1, 2, 3, 4, 4, and here 1, 2, 3, 4. So this is triple bond, and the triple bond may come in the second position. Okay. Now let us fill up comfortably. CH3, CH2. That's it. What about this? CH3, CH3, and you cannot enter anything here because it's already satisfied with 3 plus 1, 3 plus 1, 4. Leave it as such. Now you just count it, that is 1, 2, 3, 4. So C4, 3 plus 3, 6. So C4H6. And whether that formula is applicable, CnH2n minus 2. Let us check. So C4H8 minus 2, that is C4H6. So that's correct. Okay. Similarly, you can check this one also. What do you call it? This is 1-butane, right? And what about this? This is 2-butane, or you can say but-2-ine. But-2-ine. Okay, you can call by this name also, right? Now let me proceed with 5. 1, 2, 3, 4, 5. So put triple bond, fill up with hydrogen, CH3, CH2, CH, H. That's all. What do you call it? 1-pentane. Similarly, fifth member, hexane, 1-hexane. So 1, 2, 3, 4, 5, 6. Put triple bond, H, H3, H2, H2, H2. That's all. And this is CH. So what do you call it? 1-hexane. And similarly, you have 1-heptane, means 7 carbon atom. 1, 2, 3, 4, 5, 6, 7. Put triple bond. So CH3, CH2, 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 CH. That's all. So what do you call it? This is 1-heptane. Likewise, you can develop the structure and names. Okay. So we have discussed alkanes, alkynes. What is the specialty with regard to hybridization? Alkanes are sp3 hybridized. Okay, they have only single bond. They are saturated. What about alkenes? They are sp2 hybridized. Okay, they have cc double bond. Whereas these things, they have only cc bonds, single bonds only, and they are called saturated. They are saturated. Whereas this is unsaturated. Alkenes are unsaturated. They possess double bond. And alkynes are also unsaturated. And not only that, they are sp hybridized. sp3 hybridized, they have the tetrahedral structure. sp2 hybridized, they have the planar structure, triangular planar structure. Whereas sp hybridized are rod-like structure, linear structures. Okay, all kinds, tubular structures. Then let us talk about the alkyl group. Okay, let us go here. Alkyl group. Alkyl group means, that is CnH2n plus 1. CnH2n plus 1. This is alkyl group. They are represented by simply R. Okay, so the first group is, you have got methane, means cut one hydrogen, so methyl. So methyl. Okay, methyl group. And what about the next one? Ethyl. So C2H5. Ethyl group. What about the next one? Propyl, C3H7, propyl group. Next one, butyl group, C4H9, butyl group. 5, C5H11, so pentyl group. And 6, C6H, how much? Anyone? 13. Is it not? Because C6H14 is hexane. Hexyl means C6H13. That is hexyl group. Got it? Now, when you add OH to the alkyl group, it becomes alcohol. Even though it can be represented like this, but for our convenience, you can write RCH2OH also, where in this case, R includes hydrogen also. They are called alcohols. Alkanols means alcohols. So the first group, first member is CH3OH. What is this? Methanol. Methanol. C2H5OH. What is this? Ethanol. C3H7OH. Propanol. C4H9OH. Butanol. C5H11OH. Pentanol. C6H13OH. Hexanol. Okay. And similarly we have alkanols. Alkanols means that is RCHO. Alkanol. Let us start, because when I put RCHO, it includes hydrogen also, R. So you can put formaldehyde, that is methanal, HCHO. Al, don't forget Al. This is OL, this is Al, methanal. And what is the trivial name for this? Formaldehyde. Its trivial name is formaldehyde. Is a classic name. And similarly we have methanol, ethanol, CH3, CHO, ethanol. And this can be called acetaldehyde. Acetaldehyde. And we have third one, that is propanol, CH3, CH2, CHO. Okay, so propanol, Al. And butanol, CH3, CH2, CH2, CHO. Butanol, Al. Similarly CH3, CH2, 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 1, 2, 3, 4, and you have to include the CHO of aldehyde group when you count the carbon atom. So this is called pentanol, Al. And CH3, CH2, how many times? 4 times. Okay, and put CHO. What do you call it? Hexanol, Al. Got it? And we have the alkanones, which are also called ketones. Aldehydes, ketones are all called carbonyl compounds. Actually, the carbonyl compound, that group is also known as the queen of organic chemistry, because we are able to get millions of derivatives based on carbonyl group alone, and that is why almost carbonyl group dominates the entire organic chemistry, and that is why it is also known as queen of organic chemistry. What are those? Carbonyl compounds. What are carbonyl compounds? Aldehydes, ketones, carboxylic acids, and its derivatives are called the carbonyl derivatives. I will explain separately that one. Then, now we have ketone. The first member is acetone, that is CH3, C double bond O, CH3. So the general structure or general formula is RCOR. You can put prime also. And what do you call it? This is called acetone. And 1, 2, 3, that is propanone by IUPAC. Go by IUPAC. Propanone. 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 You have to be very careful about the spelling also. And this is industrially and called by the trivial name acetone. It is a very fast evaporating solvent. Then we have CH3, CH2, and then C double bond O, CH3. You know this 1, 2, 3, 4. So in the second position you have keto group and with 4 carbon atom. So it is called 2-butanone. Okay. Similarly, third one CH3, CH2, CH2, and then put C double bond O, CH3. What do you call it? 1, 2, 3, 4, okay, and 5. So pentanone. So 2-pentanone. 2-pentanone. So likewise you can try to write up to 6 members also. Then, and in fact you can change the bulkiness of the alkyl group, and thereby you will be able to get different types of ketones. For example, let me explain with pentanone. Pentanone. Here penta means 1, 2, 3, 4, 5 and 2-pentanone. So if it is 2-pentanone, then you can put double bond here O. So this is 2-pentanone. Pentanone. Now fill up with the hydrogen. CH3, CH2, CH2, CH3. So this is 2-pentanone. And shall we try 3-pentanone? Yes, we can. 1, 2, 3, 4, 5. Put double bond O here. Then it's called CH3, CH3, CH2, CH2. Okay. So this is nothing but diethyl, is it not? So we can call it by trivial name as diethyl ketone. And what about this? This is propyl, this is methyl, so you can call it methyl propyl ketone. That is by trivial name. Okay, so this is diethyl ketone. And what is the IUPAC? The IUPAC is 1, 2, 3, 4, 5. So 5 ohm. In the third position, double bond O is there. So 3 pentanone. Are you able to follow? Similarly, you have C, CH3, CH3, CH, CO, CH3. Okay, and this can be written like what about this isopropyl? Is it not? It is evenly branched, and this one methyl. So it's called methyl isopropyl ketone. Okay, methyl isopropyl ketone. And what is the IUPAC name for this? For IUPAC name, what you are supposed to do? You have to select the longest chain. So let us select the longest chain. Okay, so this is the longest chain where you can count it. And which is the essential function group? CO is the function group. So you should be given the lowest number. If you come like this, you will get 3. If you come like this, you will get 2. So you have to come like this. 1, 2, 3, 4. So in the second position, you have keto group. In the third position, you have the methyl substitution. So you can call it, that is 1, 2, 3, 4 butanone, 2 butanone, and 3 methyl. So this is called 3 methyl 2 butanone. Are you able to follow? Actually, it is rolled from pentanone, but when you write like this, based on the longest chain and the number of carbon atoms, you have to give the nomenclature. Okay. So in this case, even though it is a pentanone, but the third methyl is substituted. Okay. That's why it's called 3 methyl. So in pentanone, 1 methyl has gone. So remaining is 4. So 2 butanone. Got it? Now let me introduce a very famous industrially significant solvent, which is called Mibk. Methyl Isobutyl ketone, the very famous solvent in resin and paint industries. Now let me draw the structure. Methyl means 1 carbon atom, CH3. Isobutyl means, that is CCC. Buta means 4. So isobutyl means evenly branched butyl group. So this is the group CH3 CH CH2. Okay. Ketone, it should have C double bond O. So we should link everything. Now methyl group CH3 C double bond O, CH2 CH CH3 CH3. Are you able to follow? Now let me write down the IUPAC name for this. Now draw the longest chain. You can draw the longest chain like this. Okay. And which are all the substitution and function group? C double bond O is the function group. FG. FG means function group. Methyl group is the substituent. Okay. So number it 1, 2, 3, 4, 5. So in the second position, ketone is there. Totally 5 carbon atoms. So 2 pentanone and 4 methyl. So What is the IUPAC name for this? So the IUPAC name for this compound is 4-methyl 2-pentanone. Are you able to follow? 4-methyl 2-pentanone. Okay, so this is the way you should be able to derive the structure as well as the IUPAC name, vice versa. Clear? Next. Now let us proceed with other compounds like alkanoic acid. As I already mentioned, this can also be called carboxylic acids. Okay, carboxylic acid. Now let us practice the first acid. In fact, it should be called by general formulas RCOOH, where R represents hydrogen and alkyl groups. So here the first member is HCOOH, formic acid. And what is the IUPAC name for this? Methanoic acid. This formica means ants. So this formic acid is present in ants. So that is why it's called formic acid. Methanoic acid. And then CH3COOH. That is also called acetic acid. IUPAC, ethanoic acid. Eth means 2 carbon atom, so it is ethanoic acid. Propanoic acid, CH3, CH2, COOH, 3 carbon atom. So it's called propanoic acid. Common name is propionic acid. And similarly you have CH3, CH2, CH2, COOH. That is known as butanoic acid. IUPAC is butyric acid. It's available in butter, and that's why it's called butyric acid. And then CH3, CH2, 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 COOH. What do you call it? 1, 2, 3, 4, 5. That is pentanoic acid. That's it. So likewise hexanoic acid, heptanoic acid, octanoic acid, etc. Right? Now I was discussing about the carbonyl group. Okay, let me introduce this carbonyl group also in detail. Carbonyl compounds and its derivatives. derivatives. Carbonyl compounds generally they can be represented by C double bond O. This is the general structure of carbonyl derivatives. And why they are very specific about this? Because of its high reactivity. Let us look at the Lewis structure, the electron dot structure for carbonyl compounds. C double bond O, you have lone pair of electrons, two lone pairs of electrons. For oxygen, it has the tendency to undergo a pi electron transfer. Okay, so this double bond, that is, it may travel like this. So to become, it undergoes resonance, and so this becomes minus, this becomes plus. So it results in carbonium ion. Here, carbon with the positive ion is called carbonium ion, and this is a very reactive center, and that's why it can develop variety of derivatives, and it's called pi electron transfer because the transfer takes place from the pi bond. So the two lone pairs now becomes three lone pairs, and oxygen has gained one electron, so it becomes minus. Carbon has lost one electron, so it becomes plus. So cation, carbonium ion, are also called carbocation. Carbocation. And just you have to replace this by, for example, when you have R here and H here, they are called aldehydes. Okay. When you have R and C also are either same or different, then it becomes ketones. When you have R here and C double bond O, then on other side you have OH, then it becomes carboxylic acid. When you have R here and C double bond O, and instead of OH, if you have got NH2, then it's called amide. When you have C double bond O, or one side, and halogen or any chloride, then it's called acid chloride. when you have R here and C double bond O, so far we have been replacing the entire OH. Sometimes only hydrogen can be replaced. So in this case RCOOR. So this is known as, either it can be same or different R. This is called ester. Now let me explain one by one how they are formed. Let us take this aldehydes, ketones, acids. Let us consider RCH2OH. This is alcohol. When I talk about alcohol, you should study alcohol. This is known as primary alcohol. Primary alcohol. And R2CHOH, secondary alcohol. R3COH, tertiary alcohol. RCH2OH you can find here. This is the function group. OH group is the function group for alcohol. And this one is called the carbon attached directly to the functional group is called alpha carbon atom. What do you call it? Alpha carbon atom. And the hydrogen atom associated with the alpha carbon atom is called alpha hydrogen. So this alpha carbon atom has 2 hydrogen in the case of primary, whereas 1 hydrogen in the case of secondary, whereas no hydrogen in the case of tertiary. So in this way you should be able to identify the type of alcohol. Do you understand? Now let me take up the primary alcohol, or CH2OH. When it undergoes oxidation, it becomes RCHO. How it happens? Actually, that is when you heat, what happens? Water molecule is removed, and when it is oxidized, oxygen is added. You just work out, you have RCH2OH, subtract H2O, what will you get? RCH, is it not? And add oxygen, so you get RCHO, and that's why it's called alcohol. On dehydration it becomes aldehyde, so aldehyde, and this is alcohol. And this can further undergo oxidation to give RCOOH. That is, further you can add one O, so it becomes RCOOH. That is called acid, carboxylic acid. Okay. Let us consider methanol. So we have CH3OH. What happens on oxidation? This is methanol. or methyl alcohol by a epoch name. So it becomes HCHO. It's called methanal, Al, that is formaldehyde. That on further oxidation gives formic acid, methanoic acid. Is it clear? Right. Now, this similarly we can write ethanol also. What is the formula of ethanol? CH3 CH2OH. On oxidation, acetaldehyde CH3CHO, and on oxidation, acetic acid CH3COOH. Okay. This is ethanol, ethanal, ethanoic acid. What is the common name? Ethyl alcohol, acetaldehyde, acetic acid. Acetic acid is nothing but vinegar, which is used in pickles. Right. Now let us further develop. So now we have these two. That is, we know already these things, and we have just discussed aldehydes and the carboxylic acid. And ketones are obtained from secondary alcohol, whereas aldehydes are obtained from primary alcohol. Okay. Let me take the secondary alcohol CH3, CHOH, CH3. This is secondary alcohol. What is the epoch name? 1, 2, 3. And this is the long chain. It has propane, is it not? So 1, 2, 3. And OH is the functional group attached to the second carbon atom. So it should be called 2-propanol. Are you able to follow? 2-propanol. This is the epoch name. And what is the common name for this? Isopropyl alcohol. Isopropyl alcohol. Isopropyl alcohol is the common name. Now when it is oxidized using some powerful oxidizing agent, you are able to get ketone, not aldehyde. So CH3, C double bond O, CH3. Got it? So this is nothing but acetone. Acetone is the common name, and epoch name is 1, 2, 3 propanol. So 2-propanol. Now we get carboxylic acid with less number of carbon atom. So we get CH3COOH only. And this you know, which is nothing but acetic acid or ethanoic acid. You can find the there is no change in the number of carbon atom. For example, here 3 carbon atom, here 3 carbon atom, but on further oxidation it gets 2 carbon atom only. So a compound with the 2 carbon atoms. So there is a degradation of carbon atoms, the number of carbon atom in the case of oxidation of secondary alcohol. And tertiary alcohol is difficult to undergo oxidation, but by using very powerful oxidizing agent you can do it. But even in the second stage there will be a drop in the number of carbon atom. I will be explaining about this in that particular reaction. Now let us go ahead with the formation of other compounds. So I have discussed here ketone also. Now amide acid chloride ester. Now listen, let me talk about this amide. We have or C double bond O OH. What is this? Acid, carboxylic acid. Combine this with ammonia. So I am writing ammonia in this way, NH3 as NH2H, and this can combine, okay, to undergo a condensation. Condensation means any reaction associated with the removal of neutral molecules like water. So here H2O is removed. So you are able to get or C double bond O NH2. So this is, ammonia, whereas this is amide. I hope now you should be able to understand how the amides are formed. Similarly, let me draw one structure, CH3 C double bond O OH plus ammonia NH2H. So what will you get? That is, you are able to get CH3 C double bond O NH2. What do you call this compound? Anyone? This is acetic acid or ethanoic acid. This is ammonia. So you are able to get ethanamide. Are you able to follow? This is IUPAC name, ethanamide. Otherwise it can be called by the trivial name as acetic acid. And this is acetamide. Are you able to follow? So this is regarding the formation of amide. Right. Now we have discussed about the amide. Let us take up acid chloride and ester. Let us say CH3 C double bond O OH. So by combining with HCl you can get CH3 C double bond O, and H2 will be removed as OH minus H plus, so Cl. This is known as acid chloride, acetyl chloride. And IUPAC is ethanoyl chloride, because from ethanoic acid it is obtained. So ethanoic acid, since it's obtained from the chloride is obtained from ethanoic acid, it can be called ethanoyl chloride. Okay, for example, general nomenclature is RCOOH. From this, chlorine is removed, water is removed, so you are able to get RCOCl. So this is the general reaction. So this is alkanoic acid. And what is the general nomenclature for this? Alkanoyl chloride. Okay. So you should be able to get different types of alkanoyl chloride. Similarly, esters can be. When I say chlorine, not only chlorine, bromine, iodine, etc. So alkanoyl bromide you can have by adding with HBr. Then esters. Esters are very popular compounds. When an acid and alcohol combine, it gives ester and water. Ester and water. For instance, RCOOH, this is ROH, so you are able to get RCOOR plus water, H2O. So what is the structure of ester? RCOOR. Now let us discuss about different types of esters. Let me start with formic acid. This is acid, this is alcohol. So let us take HCOOH. What is that? Formic acid. Acetic acid, CH3COOH. Ethanoic acid. Then propionic acid, CH3CH2COOH. Here let me take different types of alcohol. Methanol, CH3OH. Ethanol, CH3 CH2OH, propanol, CH3 CH2 CH2OH, propanol. Now let me combine these two. Okay, so what will I get? That is HCOO CH3. Are you able to follow? So this OH and this H, so that you are able to get HCOO CH3. It means you have this HCOO and based on that methyl. So this is methanobate. We already know when HCO, you can take CH2 or COOH, acid. When you remove a hydrogen, it becomes carboxylate plus hydrogen. Are you able to follow? So what do you call it? This is carboxylic acid. And this one is carboxylate. So this can be called alkanoic acid. And this should be the respective alkanovate. For example, if I have CH3 COOH, it's called ethanoic acid. And what about its respective structure of carboxylate? CH3 COO minus. Are you able to follow? So this is called ethanovate. Likewise, you have propanovate, butanovate, pentanovate, methanovate, etc. Now let me combine this formic acid. What is that? This is, you have to follow me very carefully, methanoic acid. And what about this? Methanol. So when I combine this, what will you get? That is, you are removing this H and OH. So this is methyl and this is methanovate. So methyl methanovate. Are you able to follow? Similarly, by combining this, you will get CH3 COO and this one CH2 CH3. So what is the compound? This is ethanoic acid and this is ethanol. Therefore this is ethyl ethanovate. Are you able to follow? Ethyl ethanovate. Similarly, you have propionic acid. Now you can get CH3 CH2 COO and then CH3 CH2 CH3. So what do you call it? This is propyl and this one is propanovate. So propyl propanovate. Got it? Propyl propanovate. Now you can combine at random. For example, you can combine these two, okay, to get what? That is CH3 COO and CH3. So what do you call this compound? This is methyl, this is ethanovate. So methyl ethanovate is the ester. Got it? Similarly, you can combine these two. Let us combine 1 and 2. Okay? One and 2 combination. What is 1? HCOOH plus what is this? Ethanol, CH3 CH2OH. So we have to combine to give HCOO minus then CH2 CH3. What do you call this compound? This is methanovate and this is ethyl. So it should be called ethyl methanovate. Okay? So likewise we can have various combinations, but you have to be very careful about the nomenclature of these esters. Okay? Right. Now we have the alkanovate. Just now we discussed, and also we discussed about the haloalkanes, means chloroalkanes, bromoalkanes, anything. So it can be represented as RX. So the first compound is CH3 X. You can put chlorine. So chloromethane. Similarly, CH3 CH2 Cl. Okay, chloroethane. CH3 CH2 CH2 Cl. Chloropropane. And so on. Okay, and similarly alkanovate. You have or COO minus, alkanovate, that is carboxylate. HCOO minus, what do you call it? It's a group, it's not a compound. So what do you call it? Methanovate. 2 CH3 COO minus, ethanovate. 3 CH3 CH2 COO minus, propanovate. Likewise, butanovate, pentanovate, hexanovate. Okay. And just now we discussed about the various types of esters also. Let me summarize these esters. So we can have the first group as CH3 HCOO CH3. Excuse me. So methyl methanovate. Okay. Methanovate. Got it? Similarly, HCOO C2H5. We can change the alkyl group. So you will have ethyl methanovate. HCOO C3H7. And you have propyl ethanovate. Now I am changing this one. CH3 COO and I am maintaining CH3. Now what will call it? This is ethanovate. So methyl ethanovate. Are you able to follow? Methyl ethanovate. And we can go on changing this. CH3 CH2 COO CH3. What do you call it? This is propanovate. So methyl propanovate. Likewise, you can change the alkyl group in such a way that you can have different types of esters. Methyl propanovate. Is that clear? So with this, let me conclude this lecture, and I will continue the third part in the next session. If you got any doubt, you can ask me in the comment column.